G'day students, welcome to the next lesson of our matrices unit. We're now going to chapter 5i. In the previous chapter that you would have completed would have been 12b. So I know we're jumping around a bit with the exercises, but just bear with me as it will help you. So 5i is the next topic. And it's a little bit more interesting than the other ones, okay? Because there are some practical applications or real world applications where these matrices and what says here encoding and decoding is used when it comes to cybersecurity, for example. I won't go through that, but let's just go through the maths and the matrices of the idea behind encoding and decoding using an inverse matrix or inverse matrices. So let's read this. Information that is stored in a matrix can be encoded, okay, by multiplying an encoding matrix. Okay, so that's an important idea here. You can encode a matrix by multiplying it with a encoding matrix. And what it does, okay, is it mixes up the numbers. If you can imagine, you've got a matrix, you multiply it with another matrix, you'll get obviously a bunch of numbers. Okay, and what happens there is that the regional information becomes mixed up. And so therefore, if you want to decode the message, okay, you need to multiply the encoded message then with the inverse. So we've learnt about this guy here before, the good old inverse matrix. Very important that you understand how to get the inverse. Okay, so what we're doing here basically is encoding a message and decoding messages, okay, using matrices. And it's all basically the same principle you would have learned of multiplication, finding the inverse of a matrix, and that sort of thing, okay? So let's go through some examples and understand how this works. So the following letters to numbers table is often used. You'll find this, so make sure you familiarize yourself with this because you'll see this in your SACs and CFATs and most likely your exams. All right, so for example, A represents 1, B represents 2, C represents 3. So if I wanted to, I could write my name on a 2 by 3 matrix, right? For example, my name is Conrad, so I'm going to use C, which is 3, O, which is 15, R, which is 18. What am I up to? So, I forgot N. I don't even know how to spell my name. 14, sorry. For N. R, which is 18. A, which is 1, and then D for 4. So that's my name in a matrix form right there, because 3 is C, 15 is O, 14 is N, 18 is R, number 1 is A, number 4 is D. Okay, so that's one way of putting a message into matrix form. Okay, so you're going to be using this table very often. Now, I'll leave the numbers up there actually, so I'll put them back where they were, because that's something that you're going to be, or I might refer to it as an example. Okay, so what happens is this here, for example, is a encoding matrix. So if I wanted to send my name to somebody without anybody else knowing, what I would do is I would actually multiply these two together. And you can imagine what would happen if I multiplied this row with that column, this row with that column, this row with that column. Oops, sorry, pen went nuts. Okay, it mixes up the numbers, yeah? No one's going to know what the original, well, the numbers are going to be so mixed up. For example, this one's going to be 2 by 3 is 6, and then 3 by 18 is, that's a big number. Basically, it's a number that's greater than 27. So this number, if I was to encode it, okay, you'd have some crazy numbers like this. And it'd be impossible for anybody to actually try and decipher the message, because none of these numbers exist in this table here. Okay, so that's the point of encoding. So, say for example, okay, let's do a question here. The message 7 p.m. has been converted into numbers using the table above and stored as a 2 by 4 matrix. Encode this matrix using matrix C. Okay, so first things first, what you want to do is look at the message. So you'll get a question like this in the SAC. You need to look at the message and put it in matrix form using those numbers. So 7 p.m. Be mindful of all the letters. So from A, that equals 1. and z equals 26. 27 is the space, but sometimes you might see the number 0 as space. I've seen it before, but just be mindful of what they might use for space. Okay, so the message is 7 p.m. There's no name for that matrix, so I'll just call it, let's just call it M for message matrix. Yeah, so it's apparently a 2x4, so there's going to be 2 rows, 4 columns. So I like to lay it out like this first. I want to put the message in a matrix with the letters. So I could go S, E, V, E, and then N, and then space P, M. Okay, so some of you might go with that. Remember, it's 2 rows and then 4 columns. Okay, that's what we're working with for this matrix. Okay. I've seen some people do this as well, so just be mindful that you can do it this way. So 7, they might go P, M, and then space there. It is possible as well, it's okay. But just be mindful of how the message is constructed. See how there's a space between N and P? That means it implies that there's most likely a space there. So P and M. Okay, so that's my message matrix there. Okay, now let's convert it into the numbers that correspond to the letters in that table there. All right, so S is 19, E was 5, V is 22, and E was 5 again. N was 14, space is 27, P is 16, and M is 13. So there's the matrix, or there's the message in matrix form. Now the question for part A is we need to encode this message using matrix C. So what this is asking us to do is to basically, like I mentioned with this name matrix that I had before, you got to multiply them together. So the encoded version is going to be this C times M. Okay, because I've got to code the message, or encode it, sorry. So it's going to be matrix C, which is up here, 2, 3, 1, 2, multiply by matrix M, which is my M message right here. So it's going to be 19, 5, 22, and 5, 14, 27, 16, and then 13. Now, you don't have to do this by hand. You can actually just do it on your CAS. So that means the encoded message CM is equal to, now just be mindful, this is a 2x2, and that is a 2x4. You can't do M times C, yeah, because remember, of the middle numbers, they have to match. So those two have the same number, which is 2 columns for C, 2 rows for M, and then the outside will tell you the order of your answer. So it's a 2x4 matrix for your answer. So 2 rows, 4 columns. Okay, let's put this in a calculator. All right. So I'm literally just going to be putting this into my calc to figure out, or to encode it. So let's put it in. 2, 3. Hopefully you're familiar now with how to actually put these values in a calculator. Remember, this is your custom matrix, so it's got 2 rows and 4 columns. Okay, so 19, 5, 22, sorry, 5, 14, 27, 16. Just make sure, guys, that you double check your numbers and that you don't get any incorrect, because then your numbers here are gonna be way off. Okay, so doing that, there's my answer. Okay, 80, 91, 92, and 49, 47, 59, 54, and 31. So this is how we encode a matrix or a message. Okay, so it's basically just get the encoding matrix and multiply it with whatever your message was. That's how we encode. Now the other way around is decoding. So let's do question B. Let's read it. Question B asks us, a message was converted into numbers using this table. Using the table above, stored as a 2x6 matrix and encoded using C. The result is M. Okay, find the original message. Okay, so let's find what the original message was. I think that might be a typo. It should be 2x8, I think, but also 2x7. Oh no, sorry, it is 6. 1, 2, 3, 4, 5, 6. My bad. Okay, so let's figure out what the original message was. So what you have to do, so I mentioned it before. So if to encode a message, we get this matrix and you multiply it with that matrix, okay? That means to decode a matrix, all you got to do, okay, is get the inverse of this matrix and multiply it with the matrix that's been encoded. Okay, so let's put that to practice. So if the coding matrix is this, okay, or whatever C matrix, like I said before, so you've got the C coding matrix, all you got to do is find its inverse and multiply it with the coded message. Oh, well, in this case, it's just M, so we'll just call that M. Okay, so we're going to multiply C inverse, which is the coding matrix, or the decoding matrix. Now, because if that's the coding, the inverse would be that, which is decoding. So C inverse multiplied by the message matrix. So what we're essentially doing is now decoding for matrix M, because we've got to figure out what the original message was. So, oops, sorry. So it's 2, 3, 1, 2 for matrix C. 2, 3, 1, 2. And remember, you're inversing that and you're multiplying it with the M matrix for question B. So it's those crazy numbers that you can't really match with that matrix. So what's this going to do? Well, it's going to decode the message for us. So 107, 72, 55, 29, 26, might need a bit more space, and then 110, 67, 43, 32, 18, 17, and 65. So what does that equal? Okay, let's figure out what the original message was. All right, so let's see there. So let's put that 2, 3, 1, 2. Remember, we're going to inverse this. Oh, sorry. 1, and then this is 2. We're going to inverse this matrix, yeah? So it's the power of a -1 multiplied by the encoded message, so which was that one. So that's a 2 rows and 6 columns. So 107. And yes, you're going to have to show all of this as before you're working out. You don't have to multiply it yourself, because that's going to take a while. By hand, I mean, but at least put these into your calculator. 67 can be a bit tedious, but just make sure you watch out for your numbers. Yeah, make sure you get them all right. 5. So you multiply them together, and there it is. Okay, so let's move this aside. So the original message was this: 13, 15, 14, 4, 1, 1, 25, 27, 14, 9, 7, 8, 20. Okay, so let's decode this message. I've run out of space, I'm just going to write it on top here. Okay, so what's the message? So we're just literally going to match these numbers back with that table because we've decoded the message. So the number 13 is M, the number 15 is O, the number 14 is N, the number 4 is D, number 1 is A, number 25 is Y, so Monday. Number 27 is a space, the number 14 is always an N, the number 9 is I, The number 7 is G. The number 8 is H. And the number 20 is T. So the message, according to this, is Monday night. Oops. Okay, and that's essentially what we do when it comes to encoding and decoding these messages. Hopefully it wasn't too complicated, but if you have any questions, please ask me. I'm more than happy to help. So let's do chapter 5I, guys. If you have questions, let me know.